I had the kids take a pretest because they have a test coming up in the coming week on probability, and I wanted to see how much they knew already. And I'm grading them this weekend. So the idea is we're going to go over the pretest, make sure we check all of our work. You'll have questions crossed out that are wrong. You need to check them, put the correct answers, show all of the work for it, to make your own study guide so that you can study for the test. And we'll also play a game of Jeopardy or something similar to that to help review. But we're doing this first so that we're ready, we know what to do during Jeopardy, and it's more fun because you know the answers. So, the pretest, let's see. I have this information here. I asked you when you took the test to circle any questions that you thought were difficult and to answer what did you think you could use more practice with before the unit test. And then I gave you a cheat sheet. You're not going to have a cheat sheet on the actual unit test. And the questions on the pretest are actually labeled with like theoretical or experimental or compound probability. That's not going to be true on the unit test. This is just to help you study. So make sure you study carefully so that you'll be ready. So on the test, we have the first problem. There are colored marbles in a bag. 5 are red, 6 are blue, 4 are green, and 10 are black. The first thing I'm going to do is I'm going to add together those to get the total number of marbles in the black bag. So, there are, well, I know that 6 and 4 make 10, and then another 10 that would make 20, and then I add in the 5 and I get 25. So there's 25 total marbles in my bag. Now, first one is theoretical probability, which means it's out of possibilities. 1 marble was pulled from the bag. What is the probability it is green? Well, let's see. Let me erase my cross out so that I can read my numbers again. 4 are green, so the probability it was green is 4 out of 25 total possibilities. Okay? And that is a fraction, so I can stop. 4 out of 25. Next one, what is the probability the marble is black or blue? Black or blue. So black, there are 10. Blue, there are 6. So 10 and 6 makes 16. 16 out of 25. And it says express your answer as decimal, so I can't stop there. There are 2 ways to get this as a decimal. Either get 100 on the bottom, which would be times 4. Because, it's like quarters, 25 cents. 4 quarters makes $1. Get 100. 16 times 4 would be 64. So I get 0.64, 64 hundredths. Or I could have used my calculator. Calculators will be allowed on the test, and I could have done 16 divided by 25 equals 64 hundredths. Same thing. Alright, C. What is the probability the marble pulled is not black? Well, there are 10 black, but I want not black. I want the opposite of that, so the other marbles. So if 10 are black and there are 25 total marbles, well, 25 minus 10 makes 15. So there are 15 that are not black. So it's 15 out of 25. And it says to express your answer as a simplified fraction. So I need to simplify. These are both multiples of 5. I can tell because they end in 5. So I'm going to divide by 5. And 15 divided by 5 is 3. And 25 divided by 5 is 5. So I get 3/5. Compound probability. If a marble is pulled from the bag, replaced, and another is pulled, what is the probability of selecting blue and then green? So I need the blue probability first, because for compound you find each probability first, then multiply. So the blue probability is there are 6 blue out of 25. And then the green probability is that there are 4 green. So that's 4 out of 25. Then I multiply. 6 times 4 is 24, and 25 times 25 is 625. Now this doesn't say to turn this into a decimal or to reduce or anything, so I'm just going to go ahead and leave it the way it is. 24 out of 625. Okay, experimental probability. The table below shows the possible scores for a game and the number of times each score occurred. What is the probability of scoring 5? Express your answer as a percent. Well, these are the possible scores, 10, 8, 7, 5, and 0. We're looking for the probability of scoring of 5, so we're looking at this row of the table. We're going to need to know, this is experimental probability, we're going to need to know the total number of trials, which is the number of times we got any answer, so all of these put together. So I add them up. 9 and 11 makes 20. 7 and 7 is 14. And 14 plus 6 would be 20. So 20 plus 20 makes 40. 40 total. That's the bottom of my probability fraction. Now, the top is, it's a lot of students will accidentally put 5 over 7, or they'll put 5 over 40. These might as well be green, blue, red, orange. These are labels. Could have been, what's the probability of scoring green? And the scores could have been red, blue, orange, green, yellow. This is not a part of my actual fraction. What matters is the number of times each score occurred. And 5 occurred 7 times, so the 7 is important. And I get 7 over 40. And I want to express that as a percent. So percent has 100 on the bottom, and I can't get from 40 directly to 100, so I'm going to go ahead and turn this into a decimal first and go from there. I'm going to do 7 divided by 40 to get my to get to my decimal. And I get 0.175. Now, the percent is the hundredths. So it's close to 17%, but we also have this extra 5 thousandths here. And because it's 5 or above, it tells us to give it a shove. So instead of just being 17%, we round this up to being 18%. Okay. 17% would have been close, but fully correct answer is 18% because we round. Alright, the table below shows the menu at a sandwich shop. How many different sandwiches could be ordered? You could make an organized list. You could make a sandwich that has white bread, turkey, and American cheese, or white bread, turkey, and cheddar. But I'm not going to do that. I'm not going to do all that extra work when I know that to count the number of combinations, all I have to do is multiply the options in each category. There are 2 bread options times 3 meat options times 2 cheese options, which gives me 2 times 3 is 6 times 2 is 12. So there are 12 options. 12 different types of sandwiches. Number 4, compound probability. What is the probability of tossing 2 number cubes and getting a number greater than 4 and less than 4? So we're tossing 2 number cubes at the same time, and it says compound probability, so we know we're looking for 2 independent probabilities to turn into a compound probability. A number cube always has 6 sides. You can draw a cube and you can figure that out. This is what a cube looks like. And then there's the 3 sides you can see, and then, of course, on the other side you would have 3 sides that we can't see. So there are 6 sides on a cube. And when a problem just says number cube, we generically assume it's numbered 1 through 6. 1, 2, 3, 4, 5, and 6. So the probability of getting a number greater than 4, well, there's only 2 of those, 5 and 6. So that's 2 sides out of 6, or 1/3. And then less than 4, well, that's 1, 2, and 3. So that's 3 out of 6, or half of the options. So I could do 1/3 times 1/2, and I could get 1 out of 6. And if I did not simplify, then I would have gotten 2 6 times 3 6 is 6 over 36. But 6 over 36 is the same as 1/6. It's just not simplified. This question did not ask you to simplify, so you would get credit for that. Okay. The following letter cards were placed inside a bag. They spell Loiterman. On the original printed test, it should have been prettier than this, theoretically. But changing it into a PDF killed it. So, theoretical probability. One letter is selected from the bag. What is the probability of selecting an E? Express it as a ratio. Well, I see that there are 2 E's. I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. I know that a ratio is written as number, ... number. And typically for a ratio, we're going to do the numerator on the left and the denominator on the right. So we get 2 to 10. And of course, it doesn't say to simplify, but if I did simplify, I would get 1 to 5, because this simplifies to 1/5. Compound probability. One letter is selected from a bag, replaced, and another letter is selected. What is the probability of selecting a vowel and then a consonant? And we want this as a decimal and as a percent. So first, vowel. A, E, I, or U. There's 1, 2, 3, 4, 5 vowels in this out of the 10. So that's the same as saying 1/2. And if a consonant is any letter that is not a vowel, then there must necessarily be 5 out of 10 consonants or half consonants. So it's just going to be 1/2 times 1/2. Because, again, 1, 2, 3, 4, 5. 5 out of 10 consonants, 5 out of 10 vowels, or 1/2 and 1/2. And we get 1/4, which we know as a decimal is 0.25, 25 hundredths. And as a percent is 25%. You could do that. I mean, we just should know by now that a quarter is 25%, but we can also multiply by 25 or divide on a calculator. 1 divided by 4 equals. Number 6, Frank is throwing darts at a dartboard. He hits the bullseye with the following results. He makes it, misses, makes it, misses. So, based on his result, what is the probability that he will make the bullseye on his next throw, expressed as a percent? And this is, we often say percents when we're talking about probability of something happening. 50% chance of rain. So this is not uncommon. So he throws it 1, 2, 3, 4, 5, 6 times. So there's 6 trials. He makes it. We want to know the probability he'll make it. So he makes it 1, 2, 3, 4 times. 4 out of 6. Which simplifies to 2 out of 3. But that doesn't really matter because we want it as a percent. And I know that 3 is never going to get me to a decimal bottom. It's not going to get me to 10. It's not going to get me to 100. It'll get me to 9, to 99, to 999, but not 100 or 1,000. So I'm going to need to divide. 2 divided by 3 gives me 0.66666 repeating forever, which is the same as saying, well, I would technically round it here. 6 is 5 or more, so give it a shove. So this becomes 67%. This is a challenging question, like it says. You have to be able to find area. This is actually complex because it's like a 3 or more step problem. It says if you drop a coin on the region, what is the probability the coin will not land in the square? So it says that this is a square, this is a rectangle, it's not drawn to scale. And we want to know what's the probability it will not land in the square. Well, what portion of the figure is square. So it's a 4 by 4 square. I have to remember to find area. Area is length times width. So this one, the length and the width are the same. So 4 times 4 equals 16. For this one, it's 12 by 5. So 12 times 5 equals 60. That means that 16 out of 60 of the figure is square, but we want to know the probability it will not land in the square, so that means I need to subtract the total area minus the square's area gives me 44 inches squared. So 44 out of 60 is the probability that it will land in the figure but outside the square. It's this part of the area minus this part of the area, basically. So when I simplify, I can divide that by 4. 44 divided by 4 is 11. 60 divided by 4 is 15. So it's 11 out of 50. 44 out of 60 or 11 out of 15. And if you want to turn it into a decimal, which it does not require you to, so you don't have to, but it would be 0.73, repeating forever. And all of this work, that shows the symbols that are serve as my explanation. I could also explain it with words. I could say, well, I know that I'm looking for, it's going to land in the figure. So of all the places it could land, there's 60 square inches that it could land in. But I want to know the probability that it will land not in this area. So out of the 60 square inches it could land in, I'm only looking for the 44 square inches that are not a part of the square. So it's 44 out of 60. And that's how I got my probability fraction. And then I simplified and turned it into a decimal because I felt like it. And after the pretest, you guys had some practice to do. There was an example here of how to convert. We'll do that just in case here. A bag contains 4 red marbles, 16 yellow, 5 purple, 16 blue, and 10 green. So, of course, I add that all together. 4 and 16 makes 20, plus 5 makes 25, plus 16 makes 41, plus 10 makes 51. So it's out of 51. We're looking for red or green. So red is 4, green is 10, so that's 14. That's already simplified. I can't do anything else to it. Then I turn it into a decimal by dividing. 14 divided by 51. 0.27451. I don't need all of that. What I'm going to do is take this part. 4 is 4 below, let it go. So I'm just going to drop these off, and I'm going to keep the 0.27 as a percent. I'm just keeping the hundredths place stuff, so that's 27%. And then as a ratio, it's 14 to 51. Okay, and then the only other important thing to remember is if you have a decimal that is in tenths, like if it was 2/10, that is not 2%. You have to take the hundredths place to get to a percent. So this is only tenths. To get to hundredths, we need to add a 0. Then I can take that and turn it into 20%. Okay, because this is 2%. So it's very important to recognize the difference. And the kids had some homework that's not shown on here. And that is all. Make sure you study. I want you to do well on your test, and I know you're capable of it.